Okay, this video is called What is NETosis? NETosis means a release, a suicide kamikaze method of the neutrophil, a white blood cell, to fight bacterial infections. Okay, there's more to it than that, but that's the main point. Okay, this slide right here is a kind of a complex slide. It's an overview. So this is basically a neutrophil opens up its plasma membrane and starts, in a sense, spitting out its DNA covered in antimicrobial proteins to immobilize and trap a bacteria, and then the antimicrobial chemicals to kill the bacteria. That's why the neutrophil does it. If the neutrophil can just phagocytize the bacteria, it'll do that instead of commit NETosis. There's a lot of things that can activate a neutrophil to do this. I'm going to show you some introductory material so all of this will make sense. And the reason I'm giving this lecture about NETosis is it's a very important thing with regard to blood clots, which relate to the function of the heart, function of the brain. It also has a big importance with regard to hypertension and with regard to autoimmune disease. So I'm going to go through the background introductory information, and then we'll come back to this slide and I'll make sense out of the whole thing. Okay, so here is the development of a neutrophil. A neutrophil is the most important white blood cell. About 65% of your white blood cells are neutrophils. It is the first responder that fights infections. Its job is to make sure you don't get a bacterial or a fungal infection. In general, that's the main thing it does. It starts out in the bone marrow, goes through all these phases. The important one to know is the band cell. The band cell means the nucleus looks like a continuous band, and if there's an acute infection, the bone marrow will push these cells out into the blood prematurely, and that's called a left shift with a bunch of bands. Okay, a mature neutrophil is called a segmented neutrophil, and the segmentation of the nucleus facilitates passing through narrow structures like capillaries, because the neutrophil diameter is about 14 microns, capillaries only 5 microns. So it has to distort itself to become tubular like a Tootsie Roll in order to fit through those capillaries. And having a multi-segmented nucleus makes it easier to do that. Typical red blood cell is about 7 microns, so it's easy to remember that a neutrophil is just twice as big in diameter as a red blood cell. It's about 14 microns. Here's a closer look at a neutrophil. You can see it's got a lot of these granules. These are secretory granules, and they'll contain important chemicals, for example, MPO, myeloperoxidase, that help to fight infections. And they're good at fighting infections. It's part of a catalyst enzyme to produce bleach to kill bacteria. But the problem is it can also cause a lot of collateral damage, and we're going to talk about some of that. Okay, here's an example of NETosis. So here's a neutrophil, and it's expelling its DNA out into the extracellular space. Normally the DNA is wrapped around these things called histones, which are like a spool, like, you wrap thread around a spool. But there's a couple of chemical reactions that occur to cause unwrapping of the DNA, and all these little circles are antimicrobial chemicals to help kill the bacteria. You throw this net, the DNA makes a net to throw on top of a bacteria to immobilize it, and then the antimicrobial chemicals will kill it. But there are side effects. It's also quite prothrombotic, and it can cause significant blood clots. That's a problem. And I'll talk some more about the other things related to it in just a moment. A little more physiology. Nets were not even described in the scientific literature until about 2004. Osis means death. So, necrosis means sudden death, as Nick Lane would describe, like with blood on the carpet, that's necrosis. Whereas a gradual secretive cell death is apoptosis. Ferroptosis is death associated with iron, and there's a few other subtypes of that. Okay, it's to immobilize bacteria or fungi. Let's see. Usually the neutrophil will try to phagocytize the bacteria first, because then it doesn't die. Vital NETosis means it's a subtype of NETosis where it only releases a small amount of its DNA, and it can survive a couple extra hours and even do things like phagocytize and some other things. And sometimes people describe that as being like a zombie, having incomplete DNA but still being, in a sense, alive. The decondensed chromatin that I said when you throw it outward is like a net There's also ion chelators on there. Let's see. Normally a neutrophil only lives about 8 hours. If it doesn't encounter any bacteria or anything else to do, it just returns to the bone marrow and it's removed from the system. Let's see. Elastase is another enzyme released by the granules, and that helps to open up the junctions, the tight junctions between endothelial cells if it's going to pass subendothelial for diapedesis. Let's see, what else we want to know about it. Like, what are the 4 things a neutrophil can do? It could phagocytize a bacteria, and that means eat it. It could release cytokine chemicals. It could degranulate, like we talked about, and release MPO, or it could commit NETosis. Let's see. There's a lot of autoimmune diseases strongly associated with NETosis. They call them, one way to describe them is autoimmune rheumatic diseases. That includes rheumatoid arthritis. I talked about that earlier today. I did a lecture about is rheumatoid arthritis a dental disease, because you can get it from having gum disease, and that allowing, like you got leaky gut, you can get leaky gums, and that can allow bacterial endotoxins into the blood. Because NETosis throws its inner contents of the neutrophil into the extracellular space, now the immune system sees these intracellular things that it normally hadn't seen before, and it might recognize them as foreign and initiate an autoimmune response. NETosis can be triggered by LPS, bacterial endotoxin, by bacteria themselves, by immune complexes on the Fc receptors for the antibodies, complement receptors. Things like interleukin-6 can activate it. LPS can bind to the toll-like receptors. Tumor necrosis factor can activate it. PAMPs are just pathogen-associated molecular patterns like LPS. DAMPs is damage-associated molecular patterns, like if there's damaged tissue, cell debris, that can activate it potentially. Neutrophils also have a mechanosensitive calcium channel called the TRPV4, and that thing will be stimulated by severe hypertension, which is bad, because severe hypertension, if it causes these neutrophils to undergo NETosis, then you're throwing all this thrombotic material around, and that can cause accumulation of atherosclerotic plaque, because atherosclerosis is a blood clot. So you don't want that. It also can make your blood thicker, increasing blood viscosity, which can contribute to worsening hypertension. That's all bad. The NETs can activate platelets, making the blood more prothrombotic. It can activate endothelial cells, having them express VCAM and ICAM. VCAM is vascular cell adhesion molecule. ICAM is, I forget the name, I think it's intracellular adhesion molecule, something like that. Not all bacteria LPS will activate NETosis. It's especially highly virulent bacteria. They're often skilled at evading phagocytosis, and these are the ones that are more likely to induce NETosis when their LPS binds to it. And that would be like Pseudomonas, H. flu, Klebsiella, Strep pneumoniae. With fungi, the small hyphae are readily phagocytized, but the large ones are too big for phagocytosis, and that'll trigger neutrophil NETosis. Vital NETosis is kind of a funny word because it's an oxymoron. Vital means living, osis means dead, so it's like living death. Okay, but what it really sort of means for medical purposes is that the neutrophil doesn't die immediately. It stays alive for a while because it's only partially released. Its DNA only opened up partially. Okay, here's a paper talking about the association of NETosis with hypertension. And what's interesting is it generates a vicious cycle. So basically the person already has hypertension, and the hypertension causes pathologic stretching of the neutrophil. And that stretching activates the TRPV4 receptors. They let calcium into the neutrophil, and that calcium entry into the neutrophil activates NETosis. Then they spew out their NETosis, and that's going to make the blood thicker and activate platelets, and all of those things are going to lead to worsening hypertension. So you potentially can get a vicious cycle going here where this contributes to hypertension, then the hypertension activates more neutrophil, and so on in a vascular circle, and that's bad. High-fat diets also lead to increased activation of neutrophils. That's another reason why you want to avoid those high-fat diets. Neutrophil extracellular traps. That's what NET means. NET means neutrophil extracellular trap. NET, NET. They found when they fished out clots, blood clots in people who had strokes or had, coronary artery disease or had peripheral arterial disease, peripheral vascular disease, they found a lot of nets in the clots, consistent with the nets being related to the clots. Okay, there's a bunch of papers about nets being associated with thrombosis in arteries and in veins. Here's just showing one how the neutrophil is leading to increased von Willebrand factor being exposed on the endothelial cell lining the arteries, and that forms its own little lattice to be prothrombotic. The platelets get activated by this, and they start initiating a clot. The neutrophils get wrapped into the clot. The red blood cells get wrapped in the clot. And this is especially in the setting of a severe infection like sepsis. But the point I'm making is that NETosis is a major contributor to this clotting, and once NETosis gets going, it activates platelets, it activates the internal and external pathways of coagulation. It's all bad. When neutrophils release their granules, they contain MPO, myeloperoxidase, which is cationic, and it damages the endothelial glycocalyx. So all of this stuff is pushing towards thrombosis, clotting, making the blood thicker, increasing the risk of an arterial occlusion or a venous occlusion with a clot. Another article, Neutrophil extracellular traps on thrombosis formation. Okay, this is all bad. And here's just showing a neutrophil traveling through the blood. It's getting activated. It releases its nets. Its nets activate platelets. It also activates the endothelium. And then you have a tendency to accumulate within the net red blood cells and platelets and cause thrombosis, and you could potentially occlude that artery. You could potentially have a TIA from this sort of stuff. Transient ischemic attack, like a mini stroke that goes away, but you don't want a repeat event, which might be more severe. Here's a normal neutrophil flowing down in a blood vessel. Here it is activating. It's going to start releasing its granules, including the MPO. That's going to damage the endothelium. And if something else activates this neutrophil, it's going to undergo NETosis and throw its DNA out there, forming this like big net, and it's a scaffold for formation of a blood clot. And these curvilinear things in this drawing are platelets. So you get all these things adding together to form a blood clot, which can occlude an artery. Not good. Now here I was just showing you that when the neutrophil expels its inner contents into the adjacent space, the histones, for example, become citrulinated. Citrulinated just means that you convert the histone arginines into citrulline, meaning that you replace a double bond to nitrogen from carbon to a double bond with oxygen. You make it into a carbonyl group. Previously it was an imine group, so carbon and nitrogen double bond is an imine. Okay, so anyways, when you make it into a citrulline, you'll also have a tendency to form antibodies to it. And these are called anti-citrulline protein antibodies, okay, and that's characteristic of rheumatoid arthritis. You'll have double-stranded DNA coming out of this neutrophil when it undergoes NETosis, and you can form antibodies to that, anti-double-stranded antibody, okay, and that's characteristic of lupus. You'll also be booting out mitochondria into the extracellular space, and they can lyse and invert and release their cardiolipin phospholipids, which are characterized by having 4 fatty acids attached to them, a very unusual special type of fatty acid from the inner mitochondrial membrane. And you'll form antibodies to that, anticardiolipin antibodies, and that's also characteristic of lupus. Not good. Okay, here's an article about periodontal disease and rheumatoid arthritis. I gave an entire talk on this earlier today, and yes, when you get leaky gums, you get increased incidence. This is just showing the reaction of citrulline, the arginine residues, amino acid on the gets converted into, on the histone protein, gets converted into citrulline. Okay. All right, here's just showing the process in rheumatoid arthritis. It gets into the synovial fluid, the nets, and they cause inflammation. Okay, here's an article showing anti-neutrophil cytoplasm antibodies associated with vasculitis, in particular with Wegener's, also called granulomatous polyangiitis. Okay, anyways, it's a bad vasculitis, Wegener's granulomatosis. It's rare, though. I only see that disease about once every 10 years. I've seen 3 cases in my life. I've been a doctor a little bit over 30 years, so it's pretty rare. But still, it's another autoimmune disease. and it's associated with NETosis and intracellular antibodies. Okay, so this is just showing those antibodies, anti-neutrophil cytoplasm antibody of vasculitis like granulomatous polyangiitis GPA from Wegener's granulomatosis. Okay, and that's autoantibodies to MPO and to something called proteinase 3. I put a plus sign on MPO because it's real cationic, positively charged. And then the other stuff is stuff we already saw. Oh, and then this is the last slide, and I was just showing you that this is sort of a much more detailed picture. This is showing that the neutrophil is activated and it'll have NETosis triggered by its toll-like receptor, TLR, binding to PAMPs, pathogen-associated molecular patterns, or LPS, the gram-negative endotoxin from the bacteria, or to antibodies that are bound to something else, immune complex-mediated activation of the neutrophil, complement activation of the neutrophil, hypertension activation of the TRPV4 calcium channels, which activate the neutrophil, DAMPs, damage-associated molecular patterns, debris can activate it in some settings. Some of these cytokine-like chemicals, interleukin A, tumor necrosis factor can activate the neutrophil to undergo NETosis. And this is just showing the clot formed on there. The little dollar sign is really just to mean stimulated or activated platelet, which will be part of the clot. And when platelets contact the NETosis, they become activated. So that's sort of like the whole big summary in one slide. So anyways, NETosis is bad. It's much more common than was previously realized. And what's the bottom line in all this? You want to avoid leaky gut and leaky gums because those can lead to NETosis. And then they can also lead to hypertension, to atherosclerosis, and to autoimmune disease. And so the good news is it's easy. Take good care of your teeth and then eat the low-fat vegan diet to prevent leaky gut and avoid all the things that tend to cause leaky gut. You got to filter your water. You want to avoid alcohol. And there was even a lecture. Actually, I might have one more slide here. Oh, yeah. I saw a talk of this guy, William Bolshevitz, and he's a pretty good gastroenterologist. McDougall knows more than he does, but he knows a lot. Excessive psychological stress can cause leaky gut because it can shut down the splanchnic blood flow to the gut. But he was talking about pure sugar, he says, can have a little bit of a leaky gut effect. I'm not so sure. Hyperglycemia can cause a leaky gut effect because, like I said, Kipchoge, the Kenya world champion marathon guy, he would take tons of sugar and pour it into his iced tea, and then he'd go run out and set the world record in a marathon. But be that as it may, they claim is that diabetic hyperglycemia increases the risk of leaky gut. So I'm not sure how significant that is, and there's a difference between a diabetic having hyperglycemia in their blood versus a world champion marathoner putting some extra glucose in their drink. So I think I would have to respect the guy setting the world record. Anyways, I hope that was helpful overview of NETosis.